First of all, I'd like to thank you everyone for joining us today. My name is Peter Liu. I'm a solution architect at Rescale. So in this webinar, we're going to look at how you can leverage Rescale's cloud HPC environment and accelerate your engineering simulation on the cloud. So Rescale really started to set out to solve a number of challenges we see in the CE industry today. If we look back in the CE industry, so simulation has really come a long way. Starting from the 60s, where we're using analog computers, as you picture here, to solve differential equations for vehicle dynamics. Then to the 70s, where finite element methods start in the aerospace industry for structural analysis. And then in the 80s and 90s, where automotive industry began to use crash analysis to reduce the cost of crash testing. Then in the late 90s to the millennium, where computation fluid dynamics for combustion and aerodynamics started, combined with the explosion of high-performance computers really pioneered by Cray. So if you look at each of those steps, that represents a significant step up of the complexity and the computational requirements of simulation. So today, we see CA engineers now running high-fidelity multi-physics simulation with tens of thousands of millions of cells routinely on high-performance clusters with thousands of cores, which really drive the need for more computation power to deliver the answer in a timely manner. And that's one of the challenges that Rescale tried to address to be able to meet these computation requirements. With Rescale, you get access to a global network of HPC infrastructure. So you have access to more than 60 data centers in 30 plus locations all around the globe. And one of the important part of Rescale ecosystem is that we partner with the best data center provider in the world, such as Amazon Web Service, Microsoft Azure, SoftLayer, etc., to provide you with these computation resources on demand. And in addition, you can also use Rescale to access your own preferred data center provider, or you connect Rescale with your own cluster. So you can use Rescale environment to access simulation directly to your own cluster, as well as to a number of cloud providers on Rescale. The second challenge we see in the CE industry is the on-premise high-performance cluster does not really meet design demand. This is the actual example of one of our customers in Detroit. This is an automotive supplier. And if you look at their usage of HPC over the period of a year, you can see that that usage is not constant. So they have deadlines where they want to really deliver a lot of designs. So they'll run a lot of different simulations. Perhaps they have some downtime where they won't run any simulations at all. So when you develop a on-premise HPC system, you really need to size it to balance the cost and the demand. If you have say in this case, a $4 million cluster, which give you the utilization rate, which will give you the usage rate like this, then you can see that, you're meeting probably half of the demand, but when you have some peak demand like this, then your job will be queued. So you'll be waiting in the queue for a long time. Now, if you want to scale it for peak usage, in this case, to meet all the computation demand that you have, then in that case, it's going to cost $20 million to scale to come up with such system. So you really need to think about when you on-premise system to balance between these two. However, when you move to the cloud, there's no need to size your system because you access to the HPC resource completely on demand. In this case, this automotive part manufacturer decided to instead go with Rescale to run their computation completely on the cloud. Now they're actually only paying somewhere between $50K to $100K per month for the workloads, where they can actually meet all the demand of their simulation, where they're only incurring a very minimum cost. And if you think about the monthly spending they are spending, this is actually about the same as the depreciation where they would purchase a 4 million system. So they're really getting the best of the both worlds. So the third challenge we see is the complexity of submitting your simulation to HPC. So some of you may have experience submitting your job to a cluster. It's a fairly involved process where you need to SCP your model or your file to the cluster. You may need to write a job submission script where it tells the cluster how many nodes you want to use, what kind of command you want to launch, and then you're going to submit that to a submit node, which has some kind of scheduler running, Torque, Slurm, PBS. That scheduler then interact with the cluster to spin up to submit a job directly there. So as I said, this is a fairly complex process where as engineers, they want to focus on getting their model solved, getting the results. And learning this complex process really delay the workflow and decrease the productivity. So what Rescale offers here is a very simple and intuitive user interface. So you can submit your job directly from the Rescale portal to any cloud provider or to your own on-premise system directly. So there's no need to learning about programming, learning about writing a bash script. You can just use a graphic interface within your browser instead of a job and submit your job to the cluster. And you can access this portal anywhere from the world. So you can access from your laptop at home, from your iPad, from your iPhone to submit a job directly to the cluster. And in a demo later, we'll show you how you can submit a ANSYS job directly to the Rescale Cloud HPC. So the fourth challenge we see here is the difficulty to maintain all the simulation software. So with all those softwares, they have new version released very, very frequently. So that's going to tie up a lot of resource to be able to maintain those codes, to maintain all those versions, to be able to optimize and to maintain the license as well. So with Rescale, we offer both use your existing license or using on-demand license in the cloud to launch your software. In addition, we manage all those software package for you. So it's a turnkey solution for you. So if you want to run ANSYS HFSS, it's a single click and choose whatever version you want to run. And the software will be automatically loaded onto the cluster. So there's no need to maintain software. And when you have a new software release, and Rescale will automatically publish and push out all the new release automatically. So you don't have to install any software at all. So as I said earlier, so this is where Rescale offers a turnkey solution. So we have a wide variety of ANSYS software already available and pre-configured on the Rescale platform. So you can easily go into Rescale, pick the software you like to use, pick the license option you want to use, and you can submit your job, within a minute. So the fourth challenge we see in the industry is really a fast-moving and fragmented hardware providing. So if you look at the different provider, different hardware architecture behind the hood, it's actually ranging from a general purpose GPU to Intel 5 coprocessor to GPUs, all the way to tensor processor unit provided by Google. Each of those processors can be useful for a particular type of simulation. However, if you maintain a on-premise system, typically you're looking at a 18-month procurement cycle. So when a new architecture come up, it'll take a lot of time, a lot of money, a lot of effort to be able to incorporate these new architecture into your infrastructure. So with the cloud, we give you immediate access to all those architectures. So you can run a CPU with this simulation today, and you will run a GPU simulation the next day. And you can determine that you can guarantee to always use the best architecture based on the simulation you're interested in. Just to give you an example, so perhaps you're running ANSYS Fluent, where you want to try the new GPU acceleration. So you want to choose a core type with GPUs. Maybe you're running ANSYS Mechanical, where you like to using a large memory node to access in a single node. Or maybe you're running HFSS, where you want to run with less nodes and with a 10 gig network. So there's a wide variety of architecture you can choose, and we're going to show you in the demo. You can actually pick the most appropriate cluster based on the simulation you're interested in. So on the high level, the Rescale platform give you a seamless cloud HPC deployment. So we take all the complexity behind the hood to deploy HPC like the one you should see on the left-hand side, and we package it and into a seamless platform access through the browser. So we take all the heavy lifting for you, and then you can just focus on submitting and sending your simulation. And Rescale is built on the bedrock of security, and that's one of the most extreme important thing to us. So some of the securities come standard in terms of segmented user access, and we're ITAR certified, we're HIPAA certified, and we also have additional certifications such as SOC 2 certification. In addition, you can integrate it with IP address restriction, single sign-on, multi-factor authorization. All those allow you to deploy Rescale platform on an enterprise level so you can manage all those security and reliability. So on top of that, we have a stack of enablement around a platform to be able to fine-tune and provision the hardware. What it means is that when we install a software, such as ANSYS Fluent, we'll make sure we deploy it in the most efficient manner to optimize the deployment so that you can really run ANSYS Fluent as fast as you could on the hardware that you choose. And that's a technology we developed behind the hood, so you don't need to worry about all those deployments, and Rescale will help you optimize that deployment behind the hood. So what it really means is that if you go into the cloud, you can really take all the complex on-premise stack with different middleware, different consulting service, and everything like that, and transform it into enterprise-level deployment, very clean, very elegant, and easy to use, completely on the cloud. So you don't need to own any hardware, you don't need to maintain anything. So all you need is a computer with a browser, and now you can run ANSYS engineering simulation on the cloud using as many processes as you like, completely on demand. And we provide a variety of different user interface tailored for different level of users. So for example, you can use Rescale Portal, which is a web interface to submit a job directly on the browser. We also support ANSYS RSM submission, where you can launch a Rescale remote desktop, launch a Workbench session, and submit your job directly to Rescale from Workbench. Rescale also provides a command line interface and API, so if you're interested in scripting, you can even bypass the entire platform here and submit your job directly from your computer using command line all the way sending the job over and getting the results completely without accessing the browser. Finally, for administrators, Rescale offer a platform on the back end to be able to manage the number of jobs that have been running. You can check the user status, and we're going to show you in a minute what it looks like for IT administrators. All right, so what we're going to do here is to show you a demo how you can run an ANSYS simulation on Rescale ScaleX platform. So let me switch to the portal here. All right. So first of all, now once you register an account on Rescale, by the way, it's completely free. So you can go to Rescale website and then sign up an account. And once you log into your account, you'll see a screen like this. So this is a screen where you have all the jobs you have currently running, and all the jobs you have run in the past will show up in this job tab where it manages all your jobs. Now let's say I want to run a ANSYS Fluent simulation. So in this case, I want to run a car aerodynamic model with ANSYS Fluent. So what you're going to do here is you go ahead and click New Job. All right, I'm going to call it My Demo Job. And we provide a very easy-to-use interface for you to work through the workflow here. So the workflow essentially is the first step is you will provide the input for ANSYS Fluent or any other software here. Then you pick which software you like to run with. And then you pick what hardware setting that you like to use. And this is where you choose a different architecture. And then you can add an optional post-processing script to pick out the results. And then when you submit, you'll run the model, and then you get the results. So it's very easy to use. And let's just walk through those steps. So the very first step is to upload your model file. So if you have your model file on your computer, you'll click Upload from this computer, and then upload the model directly to Rescale. And if you're using a modern browser, your model will be uploaded using multi-threaded uploading to max out the bandwidth. In addition, your model is fully encrypted, so only you, nobody at Rescale even can see your model file. It's encrypted at rest, and it's encrypted in transit. If you already have uploaded your model file to the cloud before, you will use this Use File from Cloud Storage option. So let's go ahead and click that. So I do have two files I'm going to use to run my aerodynamic model. So I'm going to pick this file and that file. If you're familiar with ANSYS Fluent, the case file will describe the boundary conditions and the physics, and the journal file will describe how you're going to run this model. And just to show you what and the journal file essentially saying that we're going to load this case file, we're going to initialize it, we're going to solve it for 1,000 iterations, and we're going to write the data back to a data file and case file. So those two are the input file I need to run my model. And let's go ahead and go to the next step. And this is where you pick which software you like to run. So on Rescale, we have about 220 software pre-configured, optimized, and offer you a turnkey solution to those software. And in this case, I'm going to use ANSYS Fluent. So I'm going to go ahead and pick ANSYS Fluent. And you can pick whatever version you like to use. So let's say I'm going to use the latest 18.2 version. And you can see on the down below, there's a command here. So this is a launch command where it's going to launch ANSYS Fluent on the cluster. And it's already provided you a template. So what the user really need to do here is you'll see there's a placeholder for the name of the journal file. So you just need to simply change the name to the actual name of the file that we uploaded earlier. So I think it's called a runplot.jou. And you can just go just go back one step. You can see it's run_plot.jou. And we'll replace and put in the name here in the command. This is where the command is going to launch ANSYS Fluent. And in terms of license, you have two options here. So if you already own a ANSYS license, we can connect directly to your license server. So you use the existing license option and type in your license address. And then when you run ANSYS Fluent on Rescale, it's going to check out a license from your license server. We also offer on-demand license. So if you want to use ANSYS Elastic license, pay as you go. So you would use the Use On-Demand license option here, which I'm going to use in this demo. So once you completed this software step, and let's go ahead and click Next. And this is where you will pick which hardware infrastructure you like to use. And this is really where Rescale really shines, that we give you a wide variety of choices. You can always guarantee to pick the most appropriate, most optimal hardware per simulation. So for example, if you're running a CFD model, you might want to pick perhaps a higher clock speed, maybe with slightly less RAM per core. If you're running a ANSYS mechanical model, perhaps you want to pick something with a higher RAM per core. And if you're running some GPU models with GPU accelerations, you can pick one of the GPU-enabled core types. And we have a variety of primary core types, so you can choose on the first list. And then down below, we also have some additional core type. So each of those core type corresponds to a data center provider that you see on the first slide deck I have. And you access all those core type pay as you go. So you're not committed ahead of time which hardware, which data center you're going to use. So you can always basically pick the data center you want to use per simulation. In addition, we can even integrate it with your on-premise system. So if you want to use Rescale and submit a job to your own cluster or to your preferred hardware provider, we can make it show up as a core type on the platform, like the one you see here on-premise. And that is going to interact with the job scheduler that sits on your cluster and submit a job to your cluster. So we can integrate it directly and give you a hybrid solution where you can submit a job to your own cluster or burst to the cloud with a single integrated user interface. In this case, I'm going to use this Onyx core type, which is the first choice here. This is a Haswell processor with 2.9 gigahertz, and that gives you about 3.3 gigabyte per RAM per core and a 10 gig interconnect. So down below, once you choose the number of processors, choose the type of processors, you can choose how many number of processors you want to use. So here you can pick 1, 100, or whatever number of processors you want to use. And there's really no upper limit. So you can pick as many processors as you want, as long as your model can scale that to that level. And you can access all those cores on demand. So the cost you see here is per core per hour. So it's basically a linear cost based on how many number of processors you choose. So this is a very small model. In this case, it's 2 million cells. So I'm going to actually just use 8 processors, which is sufficient for this model. All right, and you can also see the nice thing with Rescale is we're continuing integrating and adding more data center. So for example, now we have this Emery core type, which will give you access to the latest Skylake infrastructure that Intel just released. So this gives you the Xeon Skylake processor with 3 gigahertz of clock speed. All right, so once I choose the core type, choose the number of cores, and then down below, you can set a wall time. This is essentially a safety net. So this is the maximum time that you allow your job to run. In case your job gets stuck or get hanged somehow, this is the time where it will terminate the job. I know the simulation runs in about a couple of minutes, so I'm going to just set it to 2 hours. That should be more than enough. All right. So once we have this hardware step set up, and we'll click next. And the next step is where you have a optional post-processing script where you can pick out our results and do some plotting. However, we're going to skip this step for this demo, so you can always post-process afterwards and using a remote desktop. And I'm going to click the next step. So the last page is a summary page, just to make sure everything looks good to you before you submit your job. So right now we choose ANSYS Fluent 18.2, and we're running with 8 core, and this is the hardware summary on the right-hand side. So it's about 30 gigabyte of RAM and 320 gigabyte of storage. And if you're not ready to submit it right now, you can click Save, which will save the job setup, and you can come back later and submit a job. However, if you're ready to submit it right now, we'll go ahead and click Submit. And here we go. So one of the nice things running on the cloud is there's no queuing. What it means is that when you're submitting a job, it takes a few steps to spin up a cluster, but your job will be running right away. So you won't be sitting in the queue for hours. So what it does at the beginning is going to validate the input. So that means that it's going to check the command you specified, make sure there's no syntax error, make sure your account has sufficient budget and permission to submit a job. This typically takes less than a minute. The second step is starting the cluster. And this is where Rescale go to the hardware choice that you selected and then provision a cluster. So it'll spin up the cluster and it'll make sure it's optimizing it to do a latency check, make the cluster is good. And then it's going to load up the software, load up the input file onto this cluster. And the third stage is running the job. And this is where it's actually crunching the numbers, solving your model. And once the job is completed, and what it does is it's going to transfer the results back to the cloud storage and then shut down the cluster. So everything is accessed on demand. So you're only spinning up the cluster when you're running the job. So while it's starting the cluster, it typically takes somewhere between 2 to 4 minutes to provision the cluster. Just to walk through some additional features here. So you see, if you want to share this model with your colleague, you can simply click the share button. So for security reasons, this model is only accessible to your account. So if you want somebody else to look at your model file to kind of monitor the results, you can type in your colleague's email address and they have the same level. They can have the same level of access and look at the results and the job status as you are seeing here. And we also, so if you want our support team to help you, maybe you run into some issue with your model, you can always check this share with Rescale support button, and then that's going to share this model with our support team and submit a Rescale support ticket, and then our engineering team will help you out to figure out how to set a model correctly. In addition, we also offer live chat support. So if you have a quick question and you want to connect directly with our support engineer, you can click this chat window and then type in a question here. So that will connect directly with one of the support engineers if you have a quick question. So if you have a lot of model that's similar and then you want to quickly repeat the same setup, you can easily click this clone button to set up a new job. Once you click that, what it does is you're going to set up a brand new job with the exact same setting as you have in the previous job. So right now you can see this is the same input file, same launch command, and same hardware configuration. So if you want to run a different job, maybe all you need to do here is to replace this with a different case file and then maintain everything else with the same setting and click submit. So you can quickly submit many different jobs using the clone feature and to send your job over. All right, so let me go back to my job page. So one of the nice things running on the cloud is that you don't even need to leave your browser open. So once you submitted a job, everything will be automated and running on the job, running on the cloud from that point. So you can even close your browser and maybe you go back home and then connect again to check the status. If you go into your job status tab, you can see this is the list of jobs you have currently running, and right now I have one job. It's in the starting cluster stage, and I have a bunch of jobs that I have run in the past. All right, so while it's setting up, I do also want to highlight that we also have a lot of tutorial resources. If you want to try out one of the jobs yourself, you can go into our documentation center, and then we have a session for ANSYS resource. For example, we can go into ANSYS batch example, and we have a lot of different tutorials. So what you can do here is you can even just click import job setup, which will take this job and set up a job directly under your account. So you can look at the job setup, whatever command it launches and whatever hardware choice it picks, and just learn how to set up a job and click submit and send the job directly over. All right, going back to the job that we submitted. So now the job has started. You have see a screen like this. So this is where you can monitor your job live as your job is running. So what I typically do is you can look at, for example, the process output log, which show you the history of this job right now. And this screen will update it live as the model is running. So right now it's at iteration 12, and you can look at the residual for continuity, velocity, and k-epsilon. And you can also add monitor progs, or you can spit up a PNG image. Maybe you want to monitor the plot of residual. So this is the screen allows you to monitor your simulation while it's running. Make sure it's running good. If you do want to terminate a job, you just simply need to click the stop button, and it's going to shut down this job right away. In addition, you also have access directly onto the compute node using SSH. So if you want to log on to the compute node, you can do that directly from the Rescale browser. So right now, I'm actually on the compute node. So if you look at top, you can see different processes running. So this is an 8-core job. So you will notice there's 8 Fluent MPI process currently running. So there's a lot of flexibility here to help you monitor and do additional feature with your job. And once this job is completed, let me go back to one step to the job status tab. So once the job is completed, it will look a screen like this. So you have access to the output files. In this case, for ANSYS Fluent, we have the .def file and .case file, as well as the log file. You can, if you want to download everything back to your computer, you can click the download button, or you can download each individual file back to to your computer. And once the job is completed, you still have access to all the setup page to look at how many cores you have used, the status of the job. And again, you can always clone a new job if you want to submit a new job that's similar to the same setting that you have on your previous job. All right, so what I show you here is what we call a batch job. So that gives you direct access to the platform to send a job all the way going from an input file to getting a results file. So sometimes you may want to have a graphic interface of, say, Fluent or electronic desktop to be able to set up your model or to post-process your results to load up the results file back. Or maybe you just want to run directly on the remote desktop node. So with that, Rescale offers the desktop option, which allows you to spin up a remote desktop session with whatever hardware you pick and whatever software you want to load, and you will have a desktop accessible through your browser, and you can set up a job and monitor results and run the job directly even. And let me just show you how that works. So the way it works is you'll click a new customized desktop, and you can pick whatever configuration you like to use. So you can pick a basic Windows desktop all the way to a high memory, high processor, high performance desktop that you can choose. And the next step, you can load whatever software you like to load, just like the batch job you see earlier. So maybe I want to look at the Fluent results. So I load the ANSYS Fluent desktop. On the third step, you can attach a job to the desktop node. And what it means is that you will make the input and output file of this job accessible as a folder on your desktop if you want to do some pre and post processing. And once you click launch, it's going to spin up the remote visualization node. And I do have one open earlier, so let me just to show you what it looks like. So I'm going to go ahead and if you see that I spin up a remote desktop node a couple minutes earlier. And once it's fully loaded, you will see a status page called server started. And you can then hit connect button. And then we offer two different ways for you to connect. So if you prefer to use Microsoft Remote Desktop Client, you download this RDP connection file and then launch it directly using the RDP client. However, many of our customers like to use the browser directly to interact with your remote desktop node. So we have this technology that allows you to connect to your desktop directly within your browser. So let's try that. All right, so here we go. Now you can see that I'm actually using Chrome, and now I'm accessing my Windows remote desktop directly on my browser. So this would just like your regular workstation, but it's running on the cloud. So you can open up your folders, you can look at your, so I do have one job attached to it as well. So you can see I have some results file loaded on the desktop. And however you would use your own workstation, you can do that on the cloud. And one of the nice things running in the cloud is that let's say you run into a power outage, you're somehow close your browser, your computer completely shut down. You don't lose your progress. So you can simply log back in. You can, again, go back to the desktop page, connect using in-browser desktop, and then you'll pick up whatever you left off. So the desktop session will be continue running whether you're connected to it or not until you manually shut it down. So to shut it down, you'll go to here and click terminate button. And this is where the remote visualization node will stop running. So let's say I have run this aerodynamic model, which is the one that we submitted earlier. So what I can do here is just to launch a Fluent GUI, which I already did. And what I did is just to load up that Fluent results that we run. And then you can visualize the results. Right now, we're showing the static pressure contour on the surface. So you can look at the, maybe do some calculation for drag, for downforce. And it's very responsive. It's basically just like your own workstation, but it's completely running on the cloud. And you can add a lot beefier workstation configuration behind the hood. So if you prefer to run it interactively, So you can even just run this model directly on the browser. So you can open up this front browser and click run, and it will run directly there. All right, so hopefully that gave you an overview how you would use the Rescale desktop. And what we typically see our customer do is to using this desktop to do some pre-processing, maybe to prepare the model, to generate a mesh, and do some post-processing where they can load up the results onto the desktop. And the nice thing here is that because everything is running on the cloud, there's no need for data transfer. So the data is already on the cloud. So once you finish running your job, you can simply open up the remote desktop node to look at the results without a need to download the results back to your computer. All right, so hopefully that gave you a high-level overview what Rescale desktop look like and how to submit a job both in batch or launching a desktop to solve a job. In addition, I'd like to show you the main portal here. So if you like to see the system level usage, if you have a company-wide deployment, you would access to this company page on Rescale, where you can see the utilization over the period of months, for example, right now. So let me show continuous. And you can see who has the most usage, which core type has the most usage, and then what software that is used most frequently. And you can see a variety of information on this page. You can maintain the hardware filter such that we do have a variety of hardware, but maybe you want your engineering team only run this on this particular asset. So you can add a filter to that. Similarly, you can also add software filter if you want these only a subset of software showed up on your account. You can limit it only to show a number of software there. You can manage a team member, so you can assign company admin to different users. You can assign budgets to each users, to each group, or to each project. So there's a number of ways for you to manage cost. And in terms of security, we provide a complete audit log so you can access to the complete information about accessing the platform. You can assign IP access rules such that only the devices from your company network can access the platform for security. And as I mentioned earlier, we can integrate with multi-factor authorization and single sign-on. So in terms of the integration, so if you already own a license, we can provide a different number of ways to host your license. So you can cut the license directly, and we can host it directly on Rescale. You can host it on your license server, and what we can do is to do a license proxy and using SSH tunnel to connect to your license server. We can use VPN tunnel to connect directly between Rescale compute nodes to your license server. Again, there's many different ways we can work with you, make sure we can connect to your license server. All right, so that concludes the demo. So that gives you an overview from different user experience all the way from submitting a simple job to accessing using a Rescale desktop and using Rescale admin portal to manage the results. I do want to mention that you can submit it directly from a command line interface. And just to quickly show you what it looks like while I have it open. So you can even write a simple job script like this that talk about, this is the same example I ran earlier, whatever core type you want to use. And I can do Rescale submit and then submit. And it's actually going to automatically take the input file, upload it to Rescale, run the job, and then download, once it's completed, download the results back. Fully automated, so you can script it directly and bypass the platform if you like. All right. So what I want to show you now is to talk about a number of different use cases of Rescale. So while Rescale really started by two Boeing engineers, actually. So our founder, Joris and Adam, was working at Boeing to develop the wing for Boeing 787. Now, as many of you are aware, 787 get a little bit of trouble with the wing design. They're a little bit behind the schedule. So Joris and Adam was tasked to build a simulation environment to allow them to tackle critical engineering issues much faster. And they couldn't do that without with their current HPC on-premise. So what they do is they come up with a platform and then allow them to access to, on the weekend, with running their simulation on thousands of CPUs, and in the end, they're able to deliver the design a lot faster. And that's really how Rescale started. And this is another example with one of our customer, which is a rocket design company. So the challenge here is to simulate what is built right before launch. So in order to have high confidence right before launch for such complex systems, they have to run things like Monte Carlo to run various of permutation of the model to understand their design. And with that, they want to instant access to a very large cluster that they actually don't want to maintain. So that's how they come to Rescale, that they were able to speed up the development cycle by running tens of thousands of simulation right before the launch. Another example is Manor Formula One racing. So the challenge here is that they want to run track simulation on track site and determine what is the parameter they want to tweak when their race car coming to the pit. So, and each lap they will run 3,000 different simulations to understand the permutation, to understand what parameter they want to tweak, and to adjust their strategy. So with that, they can access to a high-performance computation resource behind the hood completely on demand during the race weekend. Another example is Boom Supersonic. So they're a startup company designing supersonic jets. And they are running completely on the cloud. So they don't own any hardware, and they have a turnkey solution to submit their CFD job directly to Rescale and running their simulation in a very cost-effective manner. And this is the next example, which we did a webinar a few months earlier, which is NASCAR, Richard Childress Racing. So they're running ANSYS Fluent, and they have very large models on the order of 150 million plus cells, and they're using more than 5,000 processors to run the model. So they don't need to own any HPC hardware, which will be too expensive. And with Rescale, they access completely on demand as many processors as you like, so they can run a lot of different designs when they're in the design period, and they don't need to maintain and own any hardware at all. So we're coming up to the hour. I just want to quickly summarize the benefit of the cloud. So if you have an on-premise system, you have really limited resource. So you need a scheduler. Your job will be queued. So you run one job at a time or a few jobs at a time. Now, with Rescale, with the cloud, you can potentially run all those competitions in parallel. And if you think about all the measurement of the cost on the cloud is per hour. What it means is that if you run everything in sequence versus running everything in parallel, it will cost exactly the same. And on top of that, you can tweak your hardware. You're not committed to a particular hardware, so you can separate your job to run the also run massive directly using the hardware. And in summary, Rescale platform that allows you to do a number of things. So it's a turnkey solution, and it will allow you to deliver faster time to market. So it allows you to shorten design cycle and run your simulation much faster.